Alright, welcome back. We are still getting through the course, ordinary differential equation. And here we are, application to a first order differential equations. Now, in our previous video, we looked at some of the applications, and that is application to medicine, where we looked at exponential decay and exponential growth. Very good. After that, we came to application to economics, application to chemistry, and we are still at application to chemistry. Alright, so this is the second part of the application to chemistry, which is the missing problem. The missing problem. Now, the missing problem is also called compartment analysis. So if you don't hear missing problem and you hear compartment analysis, they are all the same. Alright, so this problem in biology and engineering can be put into a framework, the framework of missing problem. Alright, so when we talk about a missing problem, it's not about anything. It's just simple, alright? In fact, when we start solving questions, you get to know that, missing problem is not difficult. This is the idea that there will be always a time. And now, in your question, you can be given that the tank is initially full or not, and all that. But the idea I'm giving to you here from this diagram is that this is the input. This is the input. That's where the input is coming from. Alright. Let's say an input of brine or gasoline or petrol or whatever. So this is the input and we have the output here. So this is the output. Alright. Now it depends. There are some questions that you will be given the output rates. Now the output rate and the input rate can be the same. Alright, but it depends on the question. That's why I said when we get into solving questions, you get to know much of this. Very good. And there are sometimes the initial field of the tank can be given to you in the question. Alright, very good. So let's look at what we have here. If A of T is the amount of substance in a tank at any time T, that means that here A of T is representing the amount of substance. The amount of substance. And the amount of substance in a tank at any time T. At any time T. Very good. Then the model in this case is the rate of change of the amount of substance is going to be equal to the rate at which the amount of substance, which is A of T, enters the tank. Alright, so when it's happening like that, then we need to subtract the rate at which A of T or the amount of substance leave the tank. So there is a case where the amount of substance is entering the tank, and there is a case where the amount of substance is leaving the tank. Very good. So that's all the idea. So now, where rate of change, you know from your calculus 1 that when we talk about rate of change, you know from your calculus 1 that when we talk about rate of change, we are talking about differentiation. Alright, we are talking about differentiation. So the rate of change of the amount of substance is equal to dA dt. Is equal to the dA dt because for the amount of substance to take, it will depend on time. So that is that. Very good. and the AT is the same as A prime of T. A prime of T. Alright, so that is what we have there. That's what we have there. Now, let's look at what the rate at which the amount of substance enters the tank is, and the rate at which the amount of substance leaves the tank also is. Very good. So let's look at that. I would like to bring it back. Alright, so we first looked at the rate of change, and we said that the rate of change is the rate at which the amount enters the tank, or the inflow rate minus the rate at which amount leaves the tank, and that is the outflow rate. So the rate of change is equal to the inflow minus the outflow. How we are getting it? The inflow minus the outflow. So now we are going to look at, or for short, the rate of change. The rate of change, and we know that the rate of change is the first derivative, or the dt is equal to the inflow, that is the inflow rate minus the outflow rate. I hope it's clear. Alright, so that's a simple way to put it. Alright, that's a simple way to put the other one that we just explained. Very good. So the rate of change is the inflow rate minus the outflow rate. So now we are going to look at what this inflow rate is and what this outflow rate is. Very good. So the inflow rate is equal to the flow rate of liquid entry times concentration of substance in liquid entry. Very good. How big again? Flow rate of liquid entry, that is the liquid entry, times the concentration of substance in liquid entry, because the liquid that will be entry, that is the inflow, there is a concentration in it. Very good. So that's that. Alright, so the inflow, there is a concentration also in it. So the inflow rate is equal to the flow rate of liquid entry times the concentration of substance in liquid entry. Alright, let's look at rate at which the amount of substance leaves the tank, and that is the outflow. So the outflow rate is equal to the flow rate of liquid existing. The flow rate of the liquid existing, that is the one leaving. Alright, times concentration of substance in liquid existing. Alright, so the inflow rate minus the outflow rate is what is equal to the rate of change. Very good. Now there is one more thing also. Now what is this concentration of substance in the liquid? So we are going to know the concentration of substance in the liquid existing, or let me say the concentration of the substance in short. So let's see how, in case the concentration of the substance is unknown, how are you going to do it? Alright. So the concentration of the substance is equal to the concentration of the substance is equal to the amount of substance in the container at any time t. Please write that for me. Is equal to amount of substance in the container at any time. So for short, it's just the amount over volume of water in the container at any time t. Amount of substance over the volume of water in the container. So you get the amount of water over the volume. The volume is the initial volume of the container that will be given to you. Alright. So now that this is clear, we can now move on to solve some questions. But always don't forget is that the rate of change of the amount of substance is equal to the inflow rate minus the outflow rate. Very good. Very good. So let's look at some questions. Alright, so we have our first question on the board. Oh, nice. A tank contains 50 grams of pure water. Alright, 50 grams of pure water. Starting at t is equal to 0. Don't forget that. A brine containing 2 RD of dissolved salt per gallon flows into this tank at the same rate of 3 gallons per minute. The mixture is kept by stirring and the well-stirred aquarium. Alright, so we have our first question on the board, and that is a tank contains 50 grams of pure water. Starting at t is equal to 0. Please don't forget that. A brine containing 2 RD of dissolved salt per gallon flows into this tank at the same rate of 3 gallons per minute. That's the concept. The mixture is kept uniform by stirring, and the well-stirred mixture simultaneously flows out of the tank at the same rate again. I hope you can see that. Very good. How much salt is in the tank? How much salt is in the tank at any time? How much salt is present at the end of 25 minutes? How much salt is present after a long time? Very good. So let's start. So the first thing that we need to know is that we are going to let A of t be the amount of salt present at any time t. So solution, we let A of t be the amount of salt at any time. Very good. And the second thing you need to know is that you know that the rate of change of the amount of substance is dA dt, which is equal to rate in, that is the inflow rate minus the outflow rate. The next thing that you need to also know is that what is this inflow rate? and what is this outflow rate? So the inflow rate is a subscript in and subscript out. So the inflow rate is going to be equal to concentration in times the rate times the rate times the rate. This is not the same as this. Very good. Another thing that we need to also know is the rate out. Is the rate out. So the rate out is also going to be equal to the rate is going to be equal to the concentration out. The concentration out times the concentration out times the rate times the rate. Concentration out times the rate. In fact, I want to take my time to explain this to you. Yeah, voilà. So now, what is this concentration out? Most at times in the questions, most of the time this one will be given to you, the inflow concentration. But that of the outflow are normally not given to you. But sometimes you will be given the volume. So you know, let's move on. So now the concentration out is going to be equal to simply the amount over the volume. The amount over the volume. And not just the volume. Please wait, we haven't yet come to the question. I'm just giving you the techniques that you need in answering missing problem questions. So concentration out is equal to amount over the volume. And not only the volume, but it's supposed to be plus the change in the rates per time. So that is RT. That is the change of the rates per what? Time. Alright. So don't forget this. The inflow rate is concentration in times the rate. The outflow rate is concentration out times the rate, whereby the concentration out is equal to the amount over the volume, not just the volume, but plus the change the rate. That's what's going to help you to solve. Alright, so now let's come back to the question. A tank contains 50 gallons of pure water. So what is this 50? So this 50 is going to be the volume of the tank. That's going to be the volume of the tank. Alright, 7 RT is equal to 0. A brine containing 2 IB of dissolved salts per gallon flows into this tank at the same rate. So here, the inflow, this is full stop, take your time. So you can see that the inflow, we can see the rate to be 3. Alright? And also, since it was dissolved, 2 IB of dissolved salt per gallon flows into this tank. So that also will be their concentration. So now, the inflow rate is going to be equal to the concentration E, which is 2. Alright? Times the concentration E, that is the 2. Times the rate, and the rate is 3. Hope it's clear. Very good. Very good. Very good. Then we know that the inflow rate is equal to 6. Then we know that the inflow rate is equal to 6. Then now we come to the outflow rate. So the outflow rate is going to be equal to the concentration out and the rate. Now, let's go to the outflow. The mixture is kept uniform by stirring, and the well-stirred mixture simultaneously flow out. So that is the outflow rate. Flow out of the tank at the same rate. So we are using this. In fact, this one, let's clear up this same. At the rate of this. So when it comes to the outflow, then it now comes and say the same rate. Like this. The same rate. Alright. So yeah, for the outflow, the rate is unknown, but it is specifying here that it is the same as the inflow. So that is telling us that the rate here is 3. Let's continue. If this concentration out is going to be given or not. Alright. Oh, the question is done. How much salt is in the tank at any time? This we have to go for the equation. That is the particular solution. Alright. So now you can see that the concentration out is unknown. Unlike the inflow, the concentration in was known, but here is unknown. So therefore, we need to take our time. We need to take our time and go for the concentration out. So what is the amount? What is going to be the amount then? So what is going to be the amount there? Like I want you to do something. I don't say think through the question. Some too small. What is going to be the amount there? Alright, sorry. Now, so the amount is also unknown. You can see that for the out, the amount is unknown, and in fact, most of the times it's normally unknown because it needs to form something in the differential equation. Because in the differential equation, it's always embedded with the derivative and the function. Alright, so let's look at it. So the A over the volume, what is the volume? That one is 50 plus the change of the rate. Even though the question says the same rate, but yes, I want you to break it because not all the time you see it to be the same rate. That's why it's a group. They ignore. That's why it's a group. They ignore this part. So the formula I gave you previously, I told you that the amount over the volume. But coming here to give you the techniques to solve the question, I'm now adding plus change in weight. I know the reason why. So here it's going to be 3 minus 3. Sometimes if the rates are not the same, let's say this is 5, this is 2, you need to subtract to add to the volume. Alright. So that is that for that. And this is going to be simplified to. So now let's simplify this. So this is going to be A over, this is 0, alright? So A over 50. A over 50. How we can see from there? A over 50. Very good. So now, we now go to calculate for the rate out. I think we can do that. Okay, so now I can clean the question. But before that, we will be using that during the question, so don't forget it. Alright, so now the rate out is going to be equal to the concentration out times the rate itself. So the concentration out is now A over 50 times the rate. Same rate. So the rate is 3. So the rate is 3. And this going to give you 3A over 50. 3A over 50. Alright. Very good. What is the next thing to do? Then we go to write the IVP. Let's go and write the IVP. Don't forget, let's write it in this form. The rate of change, therefore the rate of change, which is dA dt or A prime of t is equal to rate in. So what's the result of rate in? 6. Cheap. It's not difficult. Minus the rate out. And what's the result of the rate out? dA 3A over 50. So now you can see something. This forming a first order differential equation. And you can see that the A prime, that is the derivative of the amount of substance, and we have the function in it. So always the A, that's why always this one will not be given to you. The concentration out. So you need to go and calculate for this. So please don't forget it. Don't forget it. If you forget, well, it's up to you. I know you are a good student and you will never forget it. Very good, you will never forget it. So now we can now go for the IVP. We can now go for the IVP. Without even take this class, it's just simple. But it's very, very important. As far as missing problem is concerned. Okay, so the IVP is very, in fact, always state the IVP, even if in the question you were not asked to state it. So that's going to be dA 6 minus 3A over 50. And what is going to be the one here? So that's the amount. We are saying that as t is equal to 0, the amount will be equal to 0. Alright. So this is what you use to get the particular solution, and that is what the A is demanding. How much salt how much salt is in the tank at any time. We are going for the particular solution. Alright. So let's solve the differential equation. So the dt, let's leave it in the proper form. Here will be plus 3A over. In fact, this part, please pause the video and do it. Any of the method that you use, it is acceptable. Any of the method you can use. Alright, so here we can identify our P of S. So here we can identify our P of S and the rest. So here our P of S, sorry, P of T. P of T will be, what is this? That is 3 over 50. Then our P of T is 6. Always make sure it's in the standard form. Okay. Then we move on to find. The integrating factor, which is the P of T 3 over 50 dt, and that's going to give you. Alright, so that is the integrating factor. Alright, then we now go and write the general solution. So A of t, please, it's not y of x. A of t, that's the amount of substance. Is equal to, you know the formula, you know how to write the formula. So it's going to be the mean times P of Alright, so by substitution, times the P of t, which is 6. Alright, so that's what we have there. This part, you know how to do that. Therefore, let's pick only the integration part and solve, and that is 6 out. So this, only this part is going to give you, only that part is going to give you, you know, here we are going to divide 6 over 3 over 50, and that's going to give you 100. That's going to give you 100. 100. So that is that for that. Then we go and do the substitution into the general solution. So A of t is going to be equal to the integration part from here to here. That is this. All these over now multiply this throughout. So we get 100 plus C used for very good. So that is that for that. That's that for that. But what we have here is a general solution. So for you to get the particular solution, then from the IDP you know that at t is equal to 0, A of 0 is equal to 0. Alright, so by substitution, A of 0 is equal to 100 plus C e raised to the power. If t is 0, then the root of this is 0. And this number raised to 0 is 1. Alright, so we know that this is 0, so here is going to be 0. Therefore, C will be equal to negative 100. So the only thing that we are left to do is to go and do the substitution to get the equation in terms of ODE, and that is the amount of substance at any time t. At any time t. C is alright, so that is that for the A. That is that for the A. So let's go for I. Let's go for the II. How much salt is present at the end of 25 minutes? How much salt is present at the end of 25 minutes? So, it's just simple. That is T is equal to 25 minutes. What is going to be that? It's just simple. So now, A of 25, wherever you see T, put 25 there, is going to be 100 minus 100. E raised to the power negative 3 over 50 times 25. So you see, the whole of the missing problem, the problem is not after getting the IBP. The problem is before getting the IBP, because if you get the IBP, how to solve a first order differential equation, I'm sure you all know how to do that. So please make sure you grab the concept well. Make sure you grab the concept well. So finally, the answer for that is going to be calculator here. Please punch your calculator and write your answer there. Punch your calculator and write your answer there. Very good. Because this can go into this. This goes here 1, it goes here 2. So this goes 2. Then punch your calculator and write the answer. Very good. So that is all for that. You can also leave it as 100 1 minus e raised to the power negative 3 over 2. You can leave it in an exact value. Let's go for C or I. See the C. How much salt is present after a long time? That is a long time. We don't know. So what we need to do is to take the limit as t approach infinity of area of t. Okay, but it is after a long time. So when you take the limit, any value that you get, that's going to be the final answer. And you can see when you take the limit of this function as t approach infinity, the result, this one goes to the result is going to be 100. So here the result is going to be 100. Alright. Then you conclude that the amount of salt is going to be present after a long time is 100. Alright. Very good. So think that is all for that in this question. Let's see what we have for the question 2. Please get a calculator now. So now this will be approximating to 77.687. Alright. Then you conclude that the amount of salt at the end of 25 minutes is that. Okay, is that, and that is going to be IBX. Alright, do the right thing. And here also, you conclude it nicely that the amount of salt present at a long time is given is 100. Is 100, but don't forget to add the unit. See you later.